We are live on YouTube. We are recording.
Numbers? Oh, it is good. Okay. At school, like all. Why does it still say it's low battery? Oh no, it's good now. At school all week, I've been like reaching for it and it's not there. I'm like, ah. Let me see. Does it do?
Just hit go live on TikTok too.
I don't have a mouse.
Have a good show.
Thanks. Oops. Oh, that's right. Okay. All right, everybody, we're back and we are totally radical. Got some rational exponents and some simplifying, more advanced radicals. So if you know what this is going to be, pop it in the chat. All right, so when we're looking at something like this, so we've got the fourth root of x to the 10th power. Okay, now usually we just work with the square roots, right? Which is just like the 2. This part is called the index. So usually if it's just a square root, that would be a 2. So this is looking at like with the fourth root of x to the 10th. Okay, so what you do is when you're simplifying this down, so the way that I look at it is you've got 10 and 10 divided by 4 is going to be 2 with a remainder of 2. So what that means is that you've got 2 groups, or 2 of these x's can come out. So that's going to be x squared. And then we've got the fourth root because what's left over is 2 x's here. Okay. Oh, over on YouTube, let's see. The Prophet. So glad I never have to do this again, but it's so fun. It's fun. Okay. Oh, ChatGPT is not good at math, actually. Okay, so 10 root 4 is 2.4. Thank you. Okay, perfect. Thank you. Oh, can you put some more water in it, please? Very strong. Yeah, just a splash. Ooh. Ooh, what a radical streak. I love that. I like your style. I like your style, Makoto. Okay, let's see. Explain inverse, tan, cosine, and sine things. Wolfram Alpha is not too bad, yeah. But ChatGPT is good for explaining topics and things like that, but it's not so great at doing like the actual calculations. But I tell my students to, to use it to explain stuff, to explain a topic. So that's pretty good. But it doesn't always work out. Oh, I can't read that. Linus, why not x raised to 10 to the fourth? So you can do that. So let me rewrite this, right? So 4 root x to the 10th. So this is the same thing as x to the 10 over 4. Okay, so when you have this rational exponent, the denominator becomes the root. It's the index of the root. And then the 10, the numerator becomes the power that x is. So this is also the same thing as x to the 5 over 2. So this would be the same thing as the square root of x to the 5th, which is, let's see, so 5 divided by 2 is, again, 2 remainder 2. So then we would have x squared square root, no, 2 remainder 1. Woo, it's been a long day, guys. x2 square root x. Remainder 1. Thank you. Okay. All right, so Maddie, graphing quadratics. Okay. So Luke, why is the reciprocal of cosine the same as cosecant? It's not. Cosine, the reciprocal of cosine is actually secant. Okay. So Lindsay, inverse trig, do you mean like being able to find the angle measurements of right triangles? Okay, so I'm getting a lot of trig questions. Awesome. Okay. So a lot of trig questions in the chat right now, which is great because I love trig. Okay, so trigonometry starts out with and is based on a lot of the relationship between the triangles, the relationship between the angles and side lengths of triangles. Okay, so when you have a right triangle here, and then you have like an angle, we use theta to mark like what angle we're kind of like talking about. Okay. Sreyunch. I'll write down composite functions. Yep, in just a little bit. Okay, piecewise functions. Ooh, lots of functions. Polynomial long division. Ooh, so many things. Okay, so let me talk a little bit about trig here. So this isn't a 0, it's a theta. So theta is where you have this, you have this like unknown angle. So this angle, or it's not necessarily an unknown angle, it's like the angle of like what you're trying to work with, right? So theta, if theta is here, this side length here is always going to be the hypotenuse, because it's across from the right angle. Sarah, I've got polynomial long division written down on my list, so I'll get to that, okay? All right, so hypotenuse across from theta, that's going to be your opposite. And then down here is your adjacent. Okay, so when you're dealing with trig, you look at these ratios, which are the relationships between these side lengths. Okay, and there's, oh, I'll add in synthetic division too. Yep, for sure. So then I've got, so my ratios, and somebody asked earlier, like, why is secant the inverse or the reciprocal of cosine? It just is. We just call them these names. So sine of theta is the ratio between the opposite and the hypotenuse. Okay. Now, no matter the size of this triangle, if this theta, whatever that angle measurement is, this will always be the relationship between the two. Okay, it will always be the relationship between the opposite and the hypotenuse. And it's always going to be the same no matter how big or how small that triangle is. It's based on that angle, the relationship between the opposite and the hypotenuse. Cosine theta is the relationship between the adjacent and the hypotenuse. And then tangent theta is the last one, which is the opposite over the adjacent. Okay, now somebody asked before about the inverse, the reciprocal. So the reciprocal of sine is cosecant, which just means that it's hypotenuse over opposite. Okay. Cosine is, secant is the, hold on. Oh, that's weird. Sorry, I'm getting a message that it's disconnected, but you guys are still here. Yep. Sreyansh, I'm sorry, I can't really read what your name is, but I've got synthetic written down also. Okay, so sine, the reciprocal of that is cosecant, which is hypotenuse over opposite. Cosine, the reciprocal of that is secant, which is hypotenuse over adjacent. Tangent, the reciprocal of that is cotangent, which is adjacent over opposite. Okay, so we've got these here. Okay, now the inverses are how you figure out an angle measurement. Okay, now inverse is different from reciprocal, right? So if I were given the opposite and the hypotenuse of a triangle, I can figure out theta by using my inverse. And the way we know it's an inverse is that -1. So if I do this, I'm going to figure out what that angle is. Okay. So we've got, if I give you a triangle like this, and I say this is theta, and this is a 3, 4, 5 triangle. Okay, and I want to figure out what that theta is. So I can figure out that theta by doing the inverse sine of the opposite over the hypotenuse. So my opposite is 3 and my hypotenuse is 5. So if I set this up, if I've got sine theta equals my opposite over my hypotenuse, so 3 over 5. Now it's also called arcsine. Yep, arcsine, arc cosine, arc tangent. So now, so that little like to the -1 power means it's inverse. It technically means that it's flipped, but it's the inverse, okay? So theta is going to be sine -1, or inverse sine, or arc sine, of 3 over 5. And this, I would just use my calculator. Ooh, it is pouring down rain outside. So I've got sine -1, or arc sine, of 3 divided by 5, and that gives me 36.86989. So theta is approximately 36.9 degrees. Now I always have my students round to the nearest whole angle, which would be 37 degrees, but 36.9 works also. Okay. All right, so Chada Lee is asking for quadratic functions. So we'll get into that in a little bit. I've got a whole long list today, guys. That's exciting. Okay, so let's get into some functions, okay? So I've got a whole list of different things about functions that people want to know. So the first thing that we want to talk about is, what is a function? Okay, so a function, and I was just doing this with some of my Algebra 2 kids this week. So a function, when we're talking about function notation, we usually stick with like f of x. F of x is usually the way that we note this. So if f of x equals 3x plus 4, okay? So this, whatever's in this parentheses is the input into here. So f of x is 3x plus 4. So f of 2, I'm going to substitute whatever is in this parentheses substitutes in for the x. So this is 3 times 2 plus 4. Now my function is always going to do the same thing. It's going to do times 3 plus 4, times 3 plus 4, times 3 plus 4, blah, 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 on and on and on. So that's going to give me, let's see, 3 times 2 is 6, plus 4 is 10. So that means that I've got f of x is 3x plus 4, so f of 2 is 10. So when I put 2 into my function, it spits out 10. Now I can graph this also. This is a graph right here. This is a linear function. Okay, the reason it is a linear function is because, oh, you are soaking wet, bud. A linear function, so when I plug in 2 here, I get 10 out. So when x is 2, 4, 6, 8, 10, spits out 10. Okay, now what about f equals 0, or f of 0? So f of 0 is going to be 3 times 0 plus 4. So that's going to give me 4. So when x is 0, this is 4. Okay? And it becomes very clear that it is y equals mx plus b, right? Your y value is the same thing as f of x. It's the same thing as the output. This graph, what this graph is really showing is it's showing you all of the values that meet this criteria, okay? So every value, including all the little in-between values, that is how you get that linear function, okay? So this function, this f of x is the same thing as y because that's like the output. Your input is your x value. So somebody asked before about compositions of functions. So that's getting into when you have more than one function going on, you can start to kind of play around with them a little bit. So we'll leave f of x as 3x plus 4. And let's say g of x is, I don't know, x squared plus 5x minus 2. Okay? So compositions of functions are very powerful. Okay, so compositions of functions are when you start combining these in different ways. So I can add these together, I can subtract them, I can multiply them, I can divide them, I can do all sorts of things. Because a lot of times when you're looking at data itself, it doesn't really match up with one clean, nice line. It might be a composition of a couple different things. Okay, and we'll talk about that a little bit more with piecewise functions too. So x squared plus 5x minus 2. So actually, thinking ahead to my piecewise function idea, let's see. So I've got x squared plus 5x minus 2. I just want to make sure that that one graphs nicely. Yep, that'll be great. Okay. All right, so what I can do is I could do something like f of x plus g of x. Right? So in that case, what I'm going to do is f of x plus g of x, I'm going to take f of x, which is 3x plus 4, and I'm going to add it to x squared plus 5x minus 2. Combine like terms, and what I get is, let's see, we've got x squared, 3x plus 5x is plus 8x, and then 4 minus 2 is plus 2. So that would be what that combined function is, okay? Okay. So now what we can do also is we can add these together or we could subtract them, but the question was really talking about those combining functions in where you've got all these different parentheses, right? So if I've got something like g of f of 2, okay, these get really confusing, right? Woof. These get really confusing, okay? But ultimately, nothing has changed. It's still what's in the parentheses gets substituted into that function. But we just have to do it twice because we're talking about both of these functions. So the easiest way that I have figured out how to like teach this or to learn this or anything is to figure out what is f of 2 first. Okay, so f of 2, because f of 2 is going to be my input for g, but I need to know what to put that in, right? So I'm going to do, all right, so f of 2, I think we already figured this one out, but that's okay. So 3 times 2 plus 4, so that's going to give us 10. So f of 2 is 10, which means when I plug in 2 to my function f, I get 10. So now what this really is asking me for is not g of f of 2, because I already know f of 2 is 10. It's asking me for g of 10. And that's going to be 10 squared plus 5 times 10 minus 2. And that's going to be 148. The concept doesn't change, right? It gets a little bit more complex or complicated, right? But it's, let's see, so we do f of 2 first and the g, exactly, Sienna. Yep. So you kind of work from the inside out. Okay. Now this could also be where you have something like, I'm going to cover this up for a second. If you had, you could just do f of g of x, right? So now there's no number, but again, it's the same idea, right? Whatever's in the parentheses is what's going into the other function. So g of x, this whole thing, I'm going to plug in to that x right there, because it's f of g of x. So I'm going to input g of x, this whole thing, into this function. So I have 3, it's 3x plus 4, but instead of just x, it's going to be x squared plus 5x minus 2 plus 4. And it is that simple. And now I'm going to distribute that 3. So I have 3x squared plus 15x minus 6 plus 4. So that's going to be 3x squared plus 15x minus 2. So if there's a number in here, plug it in separately and then kind of start to combine them. If it's just a variable, just plug them in. Just start manipulating those equations, those functions. Okay. All right. Oh, Luke. Yes, proofs are annoying. I am with you 1,000%. Let me see if we can get that. Proofs are really hard for me to do in this setting because we've got, because it's just hard for me to show you like in this situation right here. Okay. All right. So we are moving through. We're going to get to polynomial long division, but next up we've got piecewise functions, and we're going to stick with our 2 functions here and just talk about piecewise functions. Okay. So mathematicians are not super creative at naming things. Okay. We kind of call things like they are. So a piecewise function is a function that's in pieces. That's all it is. So if I've got these 2 functions, okay, let me just double check my graph. Okay, so when I've got these, usually you've got your 2 different equations, right? And so what we'll do is we'll say something along the lines of, we'll do like y equals 3x plus 4. And usually that says like if x is greater than or equal to 0. Okay. And then we'll have y equals x squared plus 5x minus 2 when x is less than 0. Okay, so again, we're just going to use these same functions that we had, right? I could say like it's going to be f of x when x is greater than or equal to 0, or I could say like g of x when x is less than 0. Okay. So this is a pretty straightforward piecewise function, right? So what we're going to look at is we've got these two functions going on, right? I'm going to go ahead and I'm going to erase these just so it doesn't get too muddled on here. Okay, but these are this is our piecewise function right here. Okay. All right. So when x is greater than or equal to 0, it's going to follow this line. It's going to be in this value. When x is less than 0, it's going to be one of these values. So what do? Well, they overlap, right? There's going to be some overlap, but we're only going to need to graph this when x is greater than or equal to 0, and we're only going to need to graph this when x is less than 0. Let's start with the linear equation first, because those are a little bit easier to graph. And then some of you were asking for graphing quadratics, so we'll get into that too. Okay. So 3x plus 4. So I know that plus 4 is my y-intercept. So I'm going to go here, right? And then I've got, let's see, 3x plus 4. So I'm going to go up 3 over 1. Up 3 over 1, down 3 over 1, down 3 over 1, right? So there's my line. But there's a problem, right? The problem is I only am following this when x is greater than or equal to 0. So I don't need any of the rest of the line, because when x equals 0, y equals 4. So here is my graph for this top part. I'm going to darken this line a little bit. For the top part here. Okay, so only when x is greater than or equal to 0 is it going to follow this line. Now, here, y equals x squared plus 5x minus 2. All right, so let's talk about graphing a quadratic, right? So the first thing I need to do is figure out my vertex, okay? My vertex, I'm going to flip this over. Okay, so graphing here, so graphing this quadratic, my vertex is going to be negative b over 2a. This is just with my coefficients. So we've got 1 is a, 5 is b, negative 2 is c. So my vertex is like my folding point, because a quadratic is going to look like a U shape or an N shape, I guess. It's a parabola. Okay, and it's perfectly symmetrical, so it's going to fold in the middle. So we've got to figure out where it folds. And the way that we figure that out is negative b over 2a. So negative b would be negative 5, and 2a is over 2. So not great. I mean, it's not lovely. So it's negative 2.5, okay? And then I'm going to see where that vertex is. It's not great, but that's okay. So my axis of symmetry is at negative 2.5. So it's along here. Okay. Now what I can also do here is my y-intercept. Yes, my y-intercept is still going to be where x equals 0, right? If I plug in 0 here, I've got 0 squared plus 5 times 0 minus 2. So when x is 0, y is negative 2. Okay. So what's really cool about this is, like I said, parabolas are symmetrical, right? They're symmetrical. They're going to fold in half. So here is 2.5 away from the axis of symmetry. So straight over 2.5 again is going to be here. Pretty cool, right? And then I can figure out, let's see, I can try out like negative 1. So when x is negative 1, right? So let me go ahead and make a little chart over here, right? When x was 0, y was negative 2. Okay, I'm making a little chart over here. A t-chart always works, right? Okay. And then when x is negative 1, which is here, so let's see, so negative 1 squared is 1, minus 5, minus 2. So we've got 1 minus 5 minus 2, so that's going to be negative 6, right? So -1 and -6 here. And then again, it's going to be symmetrical. Okay. And then when I plug in my vertex, I figure out that my vertex, oops, when I plug in like -2.5, which was my axis of symmetry, I get -8.25. So it's like -8 1/4, 2, 4, 6, 8 1/4. So it's like right here-ish. Okay. Now I don't need to go beyond here because remember, going back to the piecewise part, it's only going to follow this curve when x is less than 0. Okay. I'm going to change this to an open circle, and the reason for that is because when x equals 0, it's not on the red line, it's up here on the blue line. So now this curve around, and then it's going to go on and on and on forever. And that is a piecewise function. Okay. This is your piecewise function where you've got one part here. So when x is greater than or equal to 0, it's a straight line. It's going to follow this one. And when x is less than 0, it's going to follow this quadratic. And it's going to go back up. Okay. So that is piecewise functions. All right. So the next topic that's on my list is polynomial division. Okay, so polynomial division. I just did some of these with my students, actually. Polynomial division is one of my favorite things to do. I love it. And you can use this a lot when you're graphing polynomials and things like that. You can use it to find, to find, you can use it to find factors. You can use it to find solutions and zeros and all that kind of stuff. So let's look at one of these with long division. We'll do 2x to the 4th plus 5x cubed plus 7x squared plus 16x plus 15. We'll do that divided by, we're just going to go all in, divided by 2x plus 3. Okay. So an example of when you would use this in like an Algebra 2 class is if you are graphing this crazy polynomial, right? And you know that one of the solutions is at 2x plus 3. So you need to find some more solutions, okay? So in order to find some more solutions, you're trying to figure out what do they multiply together to get that crazy polynomial. Okay. Okay. You can do this with the Homer method, but the question was specifically for long division on polynomials. So that's why we're going to do it long division. This one's going to be really long though. Woo! What have I done? What have I done? We might need to shorten this one just so we can fit it. Yeah, I think we're gonna have to do a shorter one, guys. Sorry, because I'm worried about it fitting on the page. Okay, let's do this one instead. Let's do 2x cubed, because this one we can do synthetic also. Plus x squared minus 6x minus 8 divided by x minus 2. So the concept is still the same. Okay, it's still the same idea, is that you can use this, like if you're graphing this polynomial, this cubic polynomial, if you're graphing this and you know that one of the roots is at 2, you can use this method to figure out what the other roots are, okay? Because they're probably going to be either imaginary or irrational, things like that, okay? So 2x cubed plus x squared minus 6x minus 8. So the first thing we're going to do is we are going to set this up just like a regular long division problem, okay? So what goes inside the house is what's on top, right? So 2x cubed, I'm going to switch to a bit of a finer marker. I'm going to write this a little bit smaller. X minus 2. Okay. So we have 2x cubed plus x squared minus 6x minus 8. And then what goes out here is x minus 2. Okay. Now we're going back to like 4th grade, 3rd grade doing long division. Okay. And it's the same idea, right? We look at, okay, so this times what gives me this in here, right? You're kind of looking at all of those things. Oh my God. Sorry. All right, so I'm only going to pay attention to the first terms at any point, okay? I'm only going to pay attention. So x times what equals 2x cubed? Or you can think of 2x cubed divided by x gives me what? 2x squared. Now, I'm going to take this times this down here. So 2x squared times x minus 2. So this minus 2 is just along for the ride. 2x squared times x is 2x cubed. 2x squared times minus 2 or times negative 2 is negative 4x squared. I subtract everything, right? So 2x cubed minus 2x cubed, those cancel out. Good. X squared minus negative x squared gives me 5x squared, and I bring down the negative 6x. Okay. So remember, I'm just paying attention to these first terms. So now I'm just going to pay attention to this. So I look at x times what gives me 5x squared. So that would be x times 5x would give me 5x squared, right? I want it to be here. So Angelita, yes, we can do synthetic division on this one, but the question was first for long division. So we're going to do long division first, and then we'll look at how beautiful and amazing synthetic division is. Okay. All right. So we look at what x times what gives me 5x squared. It's going to be plus 5x. 5x times x gives me 5x squared. 5x times minus 2 gives me minus 10x. And now I subtract everything. 5x squared minus 5x squared cancels out. Negative 6x minus negative 10x gives me positive 4x. And then I bring it down. So you can see a lot of similarities between sort of like the classic long division algorithm, right? You're doing this times this here, subtract, bring the next digit down, right? But in this case, instead of bringing the next digit, I'm bringing down the next term. And I'm only focusing on those first two terms in each step. So now I'm only looking at 4x and x. So it would be plus 4. Good. Because x times 4 will give me 4x. So plus 4, and then I've got 4 times x, which is 4x. 4 times minus 2 gives me minus 8. I'm going to subtract everything. 4x minus 4x, gone. Negative 8 minus negative 8 gives me 0. So I have no remainder. So that right there gives me my solution, is that 2x cubed plus x squared minus 6x minus 8 divided by x minus 2 equals 2x squared plus 5x plus 4. Now, if I multiply these two together, x minus 2 times 2x squared plus 5x plus 4, I would get this. Oops. I would get this cubic polynomial. Okay. All right. So now this is how you would do this with long division. Now I can also do this with synthetic division. Now for me in my classes, I try to make it a little bit, now you can do synthetic division, but not for everything. So you can't always do synthetic division. You can always do long division. Long division is always going to work. Okay, synthetic division, there are some little caveats that we have with it. Okay, so let's take a look at this again. And I'm going to take this one away so we don't have to worry about that right now. Okay, so synthetic division. Right, so Angelita, I'm not sure, sorry. Only if it's linear, right? Yes. So this divisor, dividend, I never remember which one is which. Anybody have any tricks for remembering divisor, dividend? The one that would go outside the house. That's literally what I tell my students. The one that goes outside the house. It has to be linear, which means it can't be like x squared or x cubed or anything like that. I also tell my students that it's way easier, and I mean, it is. It's not like a lie that I'm telling them. It's way easier if this is a coefficient of 1. If it's linear and this is a coefficient of 1, synthetic division all day long. If it's not a coefficient of 1, you've got to use a fraction, and I know everybody hates fractions. I love fractions, but not everybody does. So synthetic division is a little bit picky, but it works, and it is so much more efficient. Okay. So the way we set up synthetic division, it's synthetic because we're only really looking at the coefficients. So I've got 2, 1, -6, and -8. So here's how I'm going to set this up. I'm going to list out my coefficients from here. 2, and I'm going to leave a little bit of space between them. 1, -6, and -8. Okay, now I've got this little bar set up here. I don't know if that has a specific name or not. I don't know. And then I'm going to make a little house here because this is going to be whatever my remainder is. Now out here, I'm going to use the opposite of this. So this is x minus 2. So out here, it's actually +2 that's going to be out here. Okay. And the reason for that is because we're really looking at like what the root is. Okay. The root of that equation. I have an orange. Let's see how the orange looks. All right. Everybody ready for synthetic division? It's amazing. Watch this. Okay. So 2, that first number, that first coefficient just gets brought down. Okay. So now I go 2 times 2 is 4. And then I add and get 5. Now I go 2 times 5, and it goes here. And I add. -6 plus 10 gives me 4. 2 times 4 is 8. And I add, and I get 0. These are my coefficients for my answer. So these are my coefficients for my answer, and it starts at 1 degree less than what I started with. So here I started with something to the third. So here, this is going to be 2x squared plus 5x plus 4. And that is my solution. And look, it's the same solution as we got with long division, but a whole lot less complicated, right? But see how you kind of set it up? You can kind of see where the coefficients are coming from, right? So if the last coefficient doesn't sum up to 0, it means that there's a remainder. Okay, so if that were like a 2, then my remainder would be plus 2 over x minus 2. That would be the remainder part. Okay, pretty fancy, right? I love synthetic division. I love dividing polynomials. So the first number, okay, I've got 2 questions here. So how did you get the 2 outside the house? So this 2 here is from this 2 here. Okay. I know there's like a bar or something. This 2 here is this 2 here. This 2 is this 2. Okay. So this first digit, yes, this first digit just gets brought down. Nothing happens to it. It just comes down. And you got 2 times 2 is 4. Add. 2 times 5 is 10. Add. 2 times 4 is 8. Add, and you get 0. So the reason it's not -2 is because when you're looking at these, it takes a little bit more, but like when you have x minus 2 is one of the things that this is divisible by. It actually means that the solution, like the root where it crosses the x-axis, is actually at +2 because it's where x minus 2 equals 0. So you can just flip it. So if you're working with polynomials and you're working with quadratics and stuff, you probably kind of maybe are picking up on what I'm putting down. But if this is totally foreign to you and you're not really sure where this is coming from, it's going to make more sense when you start graphing these, where you know that there's one of the roots is at +2 because it's x minus 2 equals 0. So x would be 2. Yeah. Okay. So now we had some questions about quadratics. Okay. All right, so some questions about quadratics. So what is a quadratic? How do we factor them? How do we graph them? All that good stuff. Okay, so let's get into quadratics a little bit. Okay. I'd rather stick with long divisions rather than guess. Long division is safer because you can always use it. But like one of those things, like when you're solving quadratics, is that like, yes, the quadratic formula works on every single one, but it's not always the most efficient way to solve a quadratic, right? Okay, so when we've got something like, if I have a quadratic function that is, yeah, we'll do this, is x squared plus 4x plus 3. Okay. So when you're asked to solve a quadratic equation, when you're solving it, it means you're trying to figure out where y equals 0. Okay, because what we're gonna do, let's see, I just want to get the graph in front of me. Because when you graph a quadratic, whoops, it's going to look something like this. Okay, now this is not the same graph for that one, but what you're really looking for is this and this. These are your zeros. These are your solutions. These are what it's called. It's like solving the quadratic or solving the function. You're trying to get to these. Now at this point is where y equals 0, right? So when you're asked to solve a quadratic, one of the first things you need to do is set it equal to 0, because that's what you're trying to figure out, right? So you would have 0 equals x squared plus 4x plus 3. Now, when I'm solving this one in particular, I have lots of options. I can try factoring it. I could complete the square, very easy. Or I can also just use the quadratic formula. Now, the quadratic formula, again, will work for any quadratic, whether it's factorable or not. But again, it's not always the most efficient. And one of the big questions on here was how to factor or factorize quadratics. So that's what we're going to talk about. That's what we're going to do on this one. And that should be the first thing that you check every time, right? So I see a couple people are already on it. You already got the answer. Excellent. Okay, but we are going to work through this a little bit more. So what we look for is any quadratic let's see. So any quadratic, when we've got x squared plus bx plus c, when we factor it, it's going to be x plus p times x plus q. Okay, it's going to go into this form when we're factoring it. Okay, now what has to happen is p plus q needs to equal b, and p times q needs to equal c. A whole lot of letters, right? A whole lot of letters there. Okay. So we've got to figure out, okay, what are two numbers, p and q, what are two numbers that multiply to 3 and add to 4? So what multiplies to 3 and adds to 4? 3 and 1. There we go. So our two values, our factored form is going to be x plus 3 times x plus 1. Okay, so that is how we would factor this. Okay, there you go. Is that better? Okay, so we've got x plus 3 times x plus 1. Now, what this means, kind of like what I was talking about earlier, like why is it positive 2 instead of negative 2, all of that, is now we've got our zeros, right? We know that when x plus 3, well, x plus 3 times x plus 1 equals 0. Now, if we have two things that are being multiplied together to equal 0, in order for that to be true, one of them has to be 0. So we've got two different ways that we can make this equal 0, right? Either x plus 3 is the one that equals 0, which means that x equals negative 3. Or maybe x plus 1 is the one that equals 0, and x is negative 1. So what that means is that x negative 3 and 0 and x negative 1 is 0. So there we've got our two zeros. Okay, that's how we're factoring. That's why we're factoring. That's what we're getting. Okay, now the other piece to this is to figure out the vertex. So to figure out the vertex with this equation, right, we need to figure out, again, it's going to be like a folding, right? It's the axis of symmetry. Okay, so we're looking at this. Okay. So to figure out the axis of symmetry, we do negative b over 2a. Negative b is negative 4. 2a is 2, so our axis of symmetry is at negative 2. That means that that is our like folding line. So I'm going to draw that in on my graph. So at negative 2, that's my axis of symmetry. That's where it's going to fold in half. Okay. And then somebody on there said, find the y-intercept now. Let's do that. So we can make a chart. So we know that the y-intercept is going to be where x is 0. Right? So that would be 0 squared, which is 0, plus 4 times 0, which is 0, plus 3, which is 3. Y2. Y2 down here will be 2 times A, which is 1. So 2 times 1 is 2. So then at 0, 3, that's here. Now what's nice about the axis of symmetry, right, is if you find one point, you actually found the other one too. Right there. Okay, now our last part is to find our vertex. Now our vertex is going to be that turning point. So in this case, it's going to be the bottom. So we want to figure out where along this line is my vertex, is my lowest point. So I know it's somewhere where x is -2. So this is -2. So then I've got -2 squared, which is +4, minus 8, which is -4, plus 3 is -1. So my vertex is at -2, -1. So now, looks like a little clown face. So now I've got my parabola, and that's my quadratic. Okay, is this grade 9? You'll see this in Algebra 1. A lot of times you will see this in Algebra 1, but definitely Algebra 2, which is usually like 10th grade. So the turning point is the vertex right here. Okay, now since this is just a quadratic with that second, it's to the second power, I know that it's only going to have that one turn. I know it's going to be a parabola like this. Now, if it were to the third or to the fourth or to the fifth power, then we would need to find more turns and more mins and maxes and all of that. But the way, that's a really good question. How would you know if it's open up or open down? You look at that A value right there. So if that is positive, it opens up, like you can fill up a cup. If it's negative, it's down. So it's pointing down. Okay. Yep, so by the A value. Yep. All right, so let's do one more of a quadratic. Let's do a we just got a couple minutes left. But let's do a factoring let's do one when we've got a number up at the front. Okay. All right. So let's do a little bit more factoring, because factoring is fun. So the vertex is the turning point. So in this case, the vertex was that point at the very bottom or at the very top if it's open down, right, where it turns. It's the very top or the very bottom of the parabola. Okay. So let's factor this one. Let's do 2x squared minus 5x minus 3. Is this factorable? Yes. Yeah, it is. All right, so this one's a little different than the last one that we did. But the only difference is that we have a 2 here, right? So instead of just looking for what multiplies to 3 and adds to 5, or -3 and -5, my favorite way to do this is using the slide and divide or slip slide and divide. Where first thing I'm going to do is I'm going to multiply 2 times -3, and I get -6. Oh, my nose is itchy. So now what I'm looking for is 2 numbers that multiply to -6 and add to -5. Okay, so I'm going to go through it. I'm going to do -6. So I know it's going to be 1 and 6, and I know it's going to be 2 and 3, right? Those are my factors. Now 6s and 5s can be really tricky because 2 and 3 can be 5, And 6 and 1 can be 5, right? So you have to really pay attention to the signs. So in this case, since it's -6 and it adds to -5, I can't do -2 plus -3 gives me -5 because -2 times -3 gives me +6. So what it's going to be is it's going to be +1 and -6. So that's going to be my two values. So I've got x plus 1 and x minus 6. Okay, because those are my two factors. Oh my gosh, my nose. Now, I'm not done yet. Because I multiplied this, I've got to now undo that. So once I have factored that, I'm going to now divide by that 2 again. So x plus 1 over 2. 1 over 2 doesn't simplify. So what happens is bottoms up. That 2 comes up here and it becomes the coefficient for that x. So we have 2x plus 1. That's one of mine. Now x minus 6 over 2. 6 over 2 does simplify and it becomes 3 over 1. So that one's going to stay because there's nothing on the bottom, so it's x minus 3. So that's how we would factor this one. Yep, you got it. Okay, somebody asked again if it opens up or opens down. This one would open up because this is positive. Okay, it would open up because this is positive. So here's my factoring, and then my zeros, right, would be at -1/2 and +3. That's where my zeros would be. And my y-intercept would be at -3. So there's a lot you can tell just from this one thing, just from this one factorable thing. Okay. A lot of teachers, I'm not sure why, but a lot of teachers, when you have this, they have you just kind of guess and check, which is really frustrating. I think it's really frustrating for students because a lot of students have a hard time just seeing it. But yeah. Do I teach factor by grouping? I do teach factoring by grouping. When you've got 4 terms, factoring by grouping really works. Now, for a long time, I taught this way. I didn't teach this way. I would teach it, I would have done this problem using factoring by grouping. Some benefits to that is that then when they saw a 4-term expression, it was no problem. They already knew how to factor by grouping. But again, a lot of students had a hard time doing the splitting and then factoring again. It just kind of added it in more and more and more. This is such a more efficient way. It is a shortcut, right? It is a shortcut. But it's a shortcut I can get behind. Okay. Teaching an honors algebra class to factor. I would probably, if it's an honors class, I would probably teach them factoring by grouping to split the middle and then factor by grouping and then show them the slide and divide. Because you can, then they actually really appreciate that this is a shortcut, right? Kind of like synthetic division is like a shortcut. But I think factoring by grouping first, so they understand how to do that. So when they see a 4-term thing, they're not totally like in the weeds about it. Yeah, generative gems, couldn't you also just put those numbers in place of the next? Exactly. So that's the factoring by grouping. That's what we're talking about, is like splitting the middle and then factoring by grouping. So I would probably teach that first, is the factoring by grouping. And I haven't gotten to this with my regular classes yet, but I probably will show them factoring by grouping first, and then go into the slide and divide. Yeah, AC is kind of like, AC is this method. AC just means you're doing A times C. So the AC method, what you do after that, that's kind of what we're talking about, is like, do you split the middle and then factor by grouping, or do you do the slide and divide method? I think they're both really good. I think there's good there's pros and cons to both. Hermes, mi amor, where did I get the divisor 2? This 2 is because we first did 2 times 3 here to get this -6. That's where that came from. So we multiplied by 2 here, so then we had to kind of undo that. Okay. How would you know what method to use? So how would you know what method to use? Meaning, would I use slide and divide, or would I use factor by grouping? So factor by grouping is really only used when you have 4 terms. So that other method that we were talking about is where you split this into plus x and minus 6x. Let me just show you guys factoring by grouping. Okay, so it's still an AC method because you're still going to look at 2 times -3. So 2 times -3, that gives me -6. Now we already kind of went through this, right? You want to look at factors that are going to add to -5 and multiply to -6. Okay, oh, I got to do my little puzzle piece here. Boop. Okay. So now, instead of doing my slide and divide method, I'm going to use my -6 and +1, and I'm going to split this middle term. So I'm going to rewrite -5x as plus x minus 6x, because that's still -5x, right? And then I haven't done anything to the 2x squared and the -3, so I'm going to leave those as they are. So -3 and 2x squared. Now now that we have 4 terms, we can factor by grouping. So factoring by grouping means I look at these first 2 terms and I get out the GCF. So 2x squared plus x, the GCF is an x, and what's left behind is 2x plus 1. Okay. Now here I look at -6x minus 3. That first term is a negative, so I've got to factor out that negative, and my GCF is 3. So I take out that -3, and I'm left with 2x plus 1. Notice that these 2 are the same. So now I'm continuing on with my factoring by grouping that I've got. Now I can take out 2x plus 1, because they're both divisible by 2x plus 1, and what's left behind is x minus 3. So I end up at the same answer. So again, if you're thinking about, if you need to teach this, right, and you're not sure which one to do, I typically will start with this one. Well, I'll really start with greatest common factor. And then I might even go into factoring by grouping first, and then add in that whole splitting the middle, kind of like showing them more and more and more. And then after we are good with factoring by grouping like this, then I'll show them slide and divide. So that's usually my typical sequence in there. But yeah. Okay. All right, let's see. Okay, so over on YouTube, Word Nerd, I'm having a hard time understanding your questions. That's why I'm not ignoring them, but I just don't understand what you're asking. Okay. So going from here to here, we're kind of pulling out. So 2x plus 1, that's going to be one of my factors. My other factor is going to be x minus 3, which is here. Okay. All right. So it is about that time. I've got a little over than an hour, but thank you for joining me. This has been great. Excellent questions, excellent work. Have a great night. I'll be back next week. If you have any questions that I didn't get to today, you can always send me a message. But you can also, if you want any like one-on-one tutoring, virtual tutoring, anything like that, you can click the link and do the stuff, and we can get into it. All right, guys, have a great night. Be safe wherever you are, and